Okay, we have randomly selected students participate in an experiment to test their ability to determine when 1 minute or 60 seconds has passed. 40 students yield a sample mean of 61.8 seconds. Assume that we have a population standard deviation of 10.5 seconds. Construct and interpret a 95% confidence interval estimate of the population mean of all students. Okay, well, first of all, notice that we know the population standard deviation right there. Remember, if it's Greek, it's a population parameter. If it's a regular English letter, then it's a sample statistic. So that means we are working in the z-score. We have a known population standard deviation. So when I look at my formula sheet, and remember the formula sheet, if you want to use it, is here under Assignments, Test Resources. I have this one available for you to download. If you come over here, you can see here I have the mean. There's our confidence interval. And we have two options for the error, the known or the unknown. We are known, so I'm using this right here. So I have that up here. Then this is the information we were given. Now, to construct this, you'll see here that they want us to find the interval here. So they want us to find this. Oh, I don't know how I just did that, but okay. We know X bar. They gave that to us right there, but we need to find E, okay? Well, I know N. They told us N. They told us sigma. They told us the population standard deviation, but I need to find the Z value. So now remember, this is our picture. We always have a two-sided symmetric. I know I can't draw, so it doesn't look all that symmetric. And we have two tails. The confidence interval is always two-tailed, and you can be reminded by the alpha divided by 2. So a 95% confidence interval means there is 5% between these two tails. So how much is in each tail? Well, half of 5% is 2.5%. So when I look up in my z-score table, I'm looking up in the body of the table here. I need to find where that 2.5 lies. So looking here, I am right here. And if it's not exact like this one is, remember the closest one. So I come back here. 0.06, 1.9. So what this means is this is negative 0.196, and this is positive 196. These are my critical values. Now, when we put this in our formula, we always use the positive. So my Z here is going to be just 1.96 because the positive and negative are going to come in. They're in this. They're over here already that I'm going to add and subtract them. So that means here I need to find out what this E is. So let's put in our known information. So I just found out this. I just looked this up, 1.96. You could do this in Excel. I prefer the table. And then down here, this is 40. So now I get out my calculator. Let's see here. Let me get out my calculator. And so I'm going to do 10.5 divided by the square root of 40. And then I'm going to times it by 1.96. So then 3.2539, something in this. Now I'm going to come back here and look. I can't find my right screen. There we go. This says 1 decimal place. So when you're rounding, keep always at least one more than it. So I'm going to probably do this to at least 2. So 3.254. Now, I would like to keep it in as long as we can, but I do know that I'm going to probably have to at least do it one way. So, there we go. Okay, so I'm going to do 61.8, so that's my X bar right there. And now I'm going to subtract my E, so I'm going to come here, bring up the answer. So 58.5, this is my first value. Now I have to do this the other way. So I've got 61.5 plus, this is what I get for trying to use the keyboard instead of the mouse. And then I have to add my 3.254. And so 65.1, because we're rounding to 1 decimal place. So I'm going to come over here, and my confidence interval is 58.5 to 65.1. So this is my confidence interval. So based on this result, is it likely the students' estimates have a mean that is reasonably close to 60 seconds? Well, yes, because 60 seconds is in that interval. So it is reasonable that 60 seconds is an option because it's in there. If I would have got this and it would have said between, 65 and 75, then no, it's not in there. The idea is we're 95% certain that the true mean is between these values. So there's a 5% chance we're wrong. That's what we decided was okay. That was what we picked as our significance level. With 95% certainty, the actual mean of all students, so based on our sample and extrapolating, of all students is somewhere in this range, which seems reasonable. That's pretty close to 60 seconds. They're doing a pretty good job of guessing this.